today we're going to talk permutations and combinations, and I will prove that I know math. So, what is the difference between permutations and combinations to begin with? Permutation is the number of possible outcomes when order is taken into account. So, if you have more than one possible outcome, there will always be more permutations than there are combinations. Let's look at some examples. Say you have 3 tests. Pass, fail, pass is one permutation. Pass, pass, fail is a different permutation because in both cases, you passed 2 tests and failed 1, but they're in a different order. So with permutations, order counts. If you have 3 options, and like your textbook shows, you have 3 options, they have 6 permutations. So red, yellow, green, and red, green, yellow, and yellow, red, green are all considered 3 different permutations. To find the number of permutations, which you will almost never need to do, if the number of options n equals 3, then there will be n factorial number of permutations. Now, if you don't remember factorial and no judgment, because I think we cover it like in high school, 9th grade or something, and a lot of us, including me, more than you all, have not been to 9th grade in a very long time. Me, much longer than you all. So, all right. So a factorial is that number times the number 1 minus that number and 2 minus that number all the way down to 1. So n factorial is 3 times 2 times 1, which equals 6. So that's how many possible permutations there are of combining 3 different options. Now, combination with 3 tests, if you have pass, fail, pass, the student passed 2 and failed 1. If you have pass, pass, fail, that's considered the same combination. The student passed 2 and failed 1. With combinations, order doesn't matter. Whether they passed the first 2 tests and failed the 3rd one, or failed the first one and passed the next 2, whatever, it's still 2 passes and 1 fail. And usually, as you will see in many examples that come up, we're more interested in combinations than permutations. So now you know the difference between the 2, but we're pretty much going to focus on combinations from here on out. Where this comes up in education, you might think it doesn't, but it actually does quite a lot. Are students being disproportionately placed in special education, you might ask? Let's say your special education class is 2 boys and 1 girl. But if your class as a whole, so the kids placed in special ed, there's 3 of them, 2 boys and a girl, but the class as a whole, you have 9 boys and 1 girl. Now the question is, hey, there's only 1 girl. There's only 1 girl out of 9, and then there's 1 girl out of 3. Is that unfair? How likely is that to happen just by chance if you're not a girl hater? To answer that question, first, you figure out how many possible combinations there are of 10 students, and then how many of them would include 1 girl, right? So then you see what is the probability in a class with 2 boys and 1 girl with all the possible combinations of 3 students. And we use combination, not permutation, because we don't care what order the boys were placed in your course or class. And we don't care if the girls were the first one you picked or the last one you picked. We're just interested in combinations. So the formula for the number of combinations for n things taken r at a time is n factorial over n minus r factorial times r factorial. That looks really complicated, but it's not. Let's say we have, and we do, 10 students, right? We have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then n minus r, because we're talking about 3, right, is 7. So we have 7 times 6 times 5 times 4 times 3 times 1. And then we have 3 times 2 times 1. All right, so this is what our whole equation looks like to find the combination of 10 things when you take 3 at a time. What's the possible combination? Because we have 10 possibilities, each one of those kids, right? So since 10 minus 3 equals 7, and if you remember from sometime early back in school about canceling things out, you can cancel out the like terms, right? Because 7 divided by 7 is 1, 6 divided by 6 is 1, 4 divided by 4 is 1, and so on. All of those are going to end up being 1. So we're going to cancel out all those like terms, 7, 6, 5, 4, 3, 2, 1, over here, and we end up with 10 times 9 times 8 over 3 times 2 times 1. And that comes out to 720, 10 times 9 times 8, over 6 equals 120. There are 120 possible combinations of 3 things, 3 selections at a time. And after I did this, I totally cheated and I verified it in Excel using the combination of 10 things, take it 3 at a time. How many possibilities are there? And sometimes I do that. I work through the combination first, just like to prove I can still do math. And that is how, if you want to find the number of combinations, you could do it in Excel. And next video, you'll find out about the binomial distribution and why this matters.